doing today is going to be called ARMssembly 1. So it says, for what arguments does this program print when with the variables 81, 0, and 3, file challenge1.s, format this right here. So if we get if we get this number, we have to transform it to hex value. So how do we solve this challenge? So for this challenge specifically, we just have to look at the specific file, which is chow.1s, which I already did. So cat chow.1s, and we get a bunch of formats. But the thing we had to focus on is this main function right here. If you see this main function right here, we see two things being focused. So we got wait, did I get the right one? Ooh, wait, I think I might have got the wrong one. chow_1.s, and this is chow_.1s. So it's this one. So with this, we see it calls this function right here, BL function, which is all this right here. But the thing we have to do is work on going behind. So we see if a equals to 0, it compares it and it checks if it equals to 0. If it's not equal to 0, it's gonna go to L4. L4, it does all of this, but it says it grabs LC1. And if you check LC1, it basically says you lose. So we have to make this function right here my bad. So we had to make this function right here win. So this function has to be equal to 0. So what are we gonna do here? So we want to look inside this function right here and like break this down and what's going on. So what this first does is basically it allocates 32 bytes onto the stack, and then from here it basically lets W0, and W0 is basically one of the first arguments of SP12. So it's gonna store the argument of W0 onto this into the stack. Now it loads. Now what we're gonna do next is basically put 81 into W0, and then from here on we're gonna 81 is now in W0, and now it's gonna get stored onto the stack at place 16. And WZR, which is currently nothing, which is 0 I guess at the moment, gets put in SP20. Now 3 is gonna get put in W0, and now 3 is now gonna get a reference at SP24. And now we have this part right here, which loads SP20, which is 0, into W0, and SP16, which currently holds 81, is gonna go to W1. And now what we're gonna do is run logical shift left, which is basically gonna shift W1, which holds 81, by W0, which currently holds 0. So a shift left, so it's gonna be something like this. It's gonna be 81. I'm gonna shift it to the left 0 times. What happens? So what does this do? Well, bishop by 0 work correctly does nothing to the operation itself. It will do nothing, but so basically it doesn't do nothing, so we just still keep 81 right here. And now SP28, which currently stores the results of this value right here, or whatever this happened. So it's gonna store it inside here. There was no shifting one, so that I'm pretty sure this holds 81, or SP28 currently holds that. And now 81 gets put in W1, SP24, which currently loads SP24, which currently holds 3 right here, and then it's gonna divide 81 divided by 3, which is 27. 81 divided by 3, which is 27. And then from if we go back right here, Now A1 27, so this now holds 27 SP28, and now we're gonna load it back into W1, and then this is basically gonna hold the 0 value, so 21, and this is 0 SP12 since it's not mentioned here, since 0. Now we're gonna put 21 minus 0. So basically the W0 is basically the load value right here. This is basically whatever the user inputs. So we need to find an input that's gonna make this 0, because at the end of the day that's basically what happens right here. So what we need to do is basically what number subtracted by 27 is gonna equal it to 0. It's basically gonna be 27. So that's what the answer is. So now that we have that, all we need to do is just wrap it around PicoCTF, and then as you see right here, I did this challenge beforehand, so we're just gonna have to do hex of 21. Hex of 21 is basically 21 hex. Hex string. Decimal to hex. Enter the decimal value 81. 27. Oh, messed up. And it's this right here. And if we go right here, it says PicoCTF, and then I put the additional zeros just to match out the layout right here. So we got 1B, because basically it's 1B, and we just added the extra zeros just to match it, because it wants it in 32-bit, and right now this is at 16. I don't know if you guys change this, probably can't. It's just adding extra more zeros. So now if we submit this, we should get the answer, and we already solved this challenge. So yeah, that's how you solve it. Nothing too difficult, nothing too hard. You might need to like Google some of the, I guess, challenge commands, but most of the time it gets it done. But yeah, that's about it. See you guys in the next one. Peace.